Hi, in this video, I will be showing you problem number 21 of chapter 14, section 5. Use the chain rule to find the indicated partial derivatives. Z equal to x to the power of 4 plus x square y and x equal to s plus 2t minus u and y equal to s t u square. Dou z by dou s, dou z by dou t, a partial derivative of z with respect to u. When s equal to 4, t equal to 2, and u equal to 1. When I use dou z over dou s, that means I am referring to partial derivative of z with respect to s. Same way, dou z over dou t, when I say that, I mean partial derivative of z with respect to t. So let's now use the chain rule, apply the chain rule that we did in our class. Z equal to f of xy is a differentiable function of x and y, where x and y are functions of two variables, namely s and t. X is a function of s and t, and y is also a different function of s and t. Are differentiable functions of s and t, then dou z by dou s, a partial derivative of z with respect to s is partial derivative of z with respect to x times partial derivative of x with respect to s, then partial derivative of z with respect to y times partial derivative of y with respect to s also. And then dou z by dou t, or partial derivative of z with respect to t, is partial derivative of z with respect to x times partial derivative of x with respect to t plus partial derivative of z with respect to y times partial derivative of y with respect to t. So this is the case when we have z as a function of two variables and x and y are functions of two variables only. But what if x and y are functions of three variables like this? Then there will be one more here. So it is dou z by, so we have to actually consider partial derivative of x with respect to, if x was a function of three variables, we have to tweak the formula accordingly. Right? So dou z by dou x equal to, now you are differentiating partially with respect to x, and then we consider z from here. Then you keep y as a constant. So you differentiate with respect to x. So it's 4x cubed plus 2xy. Then dou z by dou y, partial derivative of z with respect to y is just x square. Then partial derivative of x with respect to x, with respect to s, is 1. Because we are looking at this s plus 2t minus u. And partial derivative of x with respect to s is just the coefficient of s. Then dou y by dou s would be tu square from here. And dou z by dou s equal to 4x cubed plus 2xy, and we are using the formula now, times 1 plus x square times tu square, dou y by dou s. So we are using this formula over here. Call it A. Similarly, we are going to do for the other partial derivatives. So dou z by dou t is dou z by dou x times partial derivative of x with respect to t plus partial derivative of z with respect to y times partial derivative of y with respect to t. Here we can write partial derivative of x with respect to t now as 2. Then partial derivative of y with respect to t is su square. So partial derivative of z with respect to t would be substituting them over in the step, um, substituting them in that step, we get 4x cube plus 2xy, which is dou z by dou x, times 2 plus dou z by dou y, which is x square, which we got in the previous step A as well. So that is what we are quoting here, times dou y by dou t, which is su squared. So we got to this far. And then dou z by dou u, similarly, is dou z by dou x. Then partial derivative of x with respect to u plus partial derivative of z with respect to y times partial derivative of y with respect to u. What is partial derivative of x with respect to u? Which will be from where you are given x equal to, which is s plus 2t minus u, we are going to keep s and 2t as constants. So its derivative is going to be just minus 1, negative 1. Same way, dou y by dou u is 2stu, which is, we are given y equal to stu square. Then we are differentiating that partially with respect to u. So s and t become constants. So it is derivative of u square, which is 2u. So 2u st. So that's how we get that dou y by dou u, a partial derivative of y with respect to u. And going back to this step here, substitute. It's 4x cubed plus 2xy times negative 1 plus x squared times 2stu. Call it C, equation C. Now we've got equation A, equation B, and equation C. We can substitute the values of s, t, and u, which are given as 4, 2, and 1 respectively. We can also get the values of x and y through the values of s, t, and u. So when s equal to 4, t equal to 2, and u equal to 1, x becomes, substituting as s plus 2t minus u, you get 4 plus 4 minus 1, which is 7. So x is 7. Y is stu square. So substituting the values of st and u, we get that value to be equal to 8. We got the value of x, we got the value of y. Now substituting all these into A, we get partial derivative of z with respect to s as 1484 times 1, 1484 times 1 plus 49 times 2, which will be 1582. Then substituting all these values into B, which is partial derivative of z with respect to t, we get 1484 times 2 plus 49 times 4, which we got from B. The value turns out to be 3164. Now substituting all of this into C, we get partial derivative of z with respect to u is 1484 times negative 1 plus 49 times 16, that becomes negative 700. So we have got partial derivative of z with respect to s, partial derivative of z with respect to t, and partial derivative of z with respect to u. So it's only computational, but the principle wise, if you remember the tree diagram which we gave, that's more useful. So anytime a function, a variable is a function of, z is a function of two variables, when you take partial derivative, When you differentiate with respect to one of them, it becomes partial derivative. So for that, you use a notation for partial derivative. But when a variable, whenever a function is a function of one single variable, then you will use the derivative symbol, d symbol. Otherwise, chain rule is only an extension of what you did with chain rule in single variables in Calculus 1 class. Hope this video helps.